let's take a closer look at what happens to an electron. Everybody knows that electrons have ears and tails and smiley faces. What happens to an electron between the source and the capacitor? Well, if the capacitor doesn't have a lot of charge on it, of course the electron is attracted to all this positive charge, but not all that much. It's also attracted to the source, and if the source is strong enough, then it's got a much stronger attraction to the source. So we have a net force in this direction, which tends to make the electrons in this wire drift from the capacitor toward the source. And of course that force is the same all the way through the wire. As we've seen, the wire has the effect of extending the influence of this positive charge. This is not a Coulomb force at this point, really. It's more a voltage gradient. We have a voltage gradient, a constant voltage gradient between here and here, and that's what creates the force on the charge. Now if we look at the situation where we have more charge on the capacitor plate, the charge is denser, then we're going to experience more attraction toward the capacitor, same attraction toward the source, but the net force is much smaller, so the electrons will drift much more slowly in the direction of the source. Now if the electrons drift more slowly in the direction of the source, that means positive charge builds up here more slowly, because where are the electrons ultimately coming from? Well, as electrons drift here, we're taking electrons off of the capacitor plate. We take an electron off the capacitor plate, that leaves a charge behind. As the electrons drift more and more slowly, fewer and fewer electrons leave the capacitor plate in a given time interval, and the capacitor builds up more and more slowly. So, again we see if there's a greater charge in the capacitor, there's less force, therefore less acceleration, less average velocity, therefore less current. That's another way of looking at the situation.